So in the previous video, I showed you this relationship between the slope of y equals mx plus b and the inverse function, which would be where the slope comes out to be reciprocal, so it's 1 over m. So, and then we use that to basically come up with this new formula, which is y minus a equals 1 over m x minus b. But that 1 over m part, which is really like 1 over, I think 1 over m, which was f prime of a, is really kind of the key that I want to get in for this next piece. So imagine, then I'm going to flip in, you have some f of x that has an inverse, f to the negative 1 of x. Has that inverse at some point a, b, so that f of a equals b, okay, at some given value, at some specific point. So then, let's say we have the inverse here, which then means that's f to the negative 1 of b equals a. Let's say you wanted to find the derivative of the inverse at b. Well, the formula states then that we can really find and the reason we can do that is, as we said before, remember that f to the negative 1 of b is a, but f to the negative 1b, inverse of f at b, is actually 1 over f prime at a, which blends nicely with what we did before. Now, in the textbook, they make this harder because they take all this f of negative 1 stuff and they call it g of x. So this is g of b equals a, which makes this g of b, which makes this g of b. But all they're saying is that g of b is the inverse of f. They give it a different letter rather than an inverse, which I think makes it more confusing, at least for me, adding in this whole extra letter. But that's all they did. So let me give you a quick example. The example that I have is, let's say f is invertible. For some reason this isn't writing, trying, is invertible. Okay. Let's say f is 3 equals 2. And that f to the negative 1 is 3 of 3 equals negative 4. Find g prime of 2 if g of x equals f to the negative 1 of x. So we know from the formula g prime of 2, which is the inverse, is 1 over f prime g of 2. Remember, g is the inverse. So we're going to look at here because everything that's x is y and everything that's y is x, right? So we're going to look right here because I have g is 2 right there. Well, at g of 2, it's actually 3. It's the inverse of this function. So that means g of 2 equals 3, which means g of 2 is 3. So what I'm really trying to find is 1 over f prime at 3, which is 1 over 4. And that should be a negative. I don't know if that comes out. So it was negative 1/4. So that's how you can use that rule working with inverses. Okay, so let's go ahead and see how we can expand this beyond by taking f of x equals 4x to the third, excuse me, minus 1. And instead of having it with the formula with b, let's take a g prime of x equals 1 over f prime of g of x. So I took out the b and replaced it with x. Okay, so what we need to do first is we need to consider what f prime is. F prime of x is going to be 12x to the second power. Cool. So now we need to think what g of x is. To get g of x, we need to replace the y with the x. So x equals 4y to the third minus 1. So it's x plus 1 equals 4y to the third. And I'm going to divide by 4, so it's 1/4 x plus 1/4 equals y to the third. And then we have cubed root. And I'm going to change y, since it's my inverse, this is f to the negative 1. I'm going to change this to g of x. So f prime of g of x is not to be confused with chain rule. This is a composite. So f prime is right here, and g of x is right here. So f prime is 12, and then we pop in the cubed root, and it's both squared into the cubed root, so I'm going to call it 2/3. Okay, so now this is f prime of g. That's what this is. So 1 over this is actually the derivative. Nope, well, let me rewrite. All right, so g prime of x is actually 1 over 12, 1/4 x plus 1/4 to the 2/3. And that's how in your home fun, it looks like you're going to have problems 3 and 7 asking you to consider with that formula 3, 7, 11, 15 in your home fun. Those are all pertaining to that formula. I think once I move on to 23, they actually just want you to find the derivative using the rules that we're going to go over in the next video. Okay?